Hi, in this video we're going to be taking a look at an application of integration. So in this video we're going to be taking a look at the area between two curves. So say we have two functions, f of x and g of x, and want to know the area between them. So if we have f of x and g of x graphed right here, what we can do is find the area, say, of this pink region, of the area between f of x and g of x between the points A and B. Now there's two ways to think about this. So the first way is we can take the area of f of x and the line x equal or y equals 0. So this is just the standard integral of f of x dx from a to b. And then we can take the area below the curve of g of x. And so the area of g of x, which is going to be the integral from a to b of g of x dx. And then we can just subtract those, and we get the area between f of x and g of x. And by linearity, we can just go ahead and take f of x minus the integral of g of x and bring that all under one integral, which is f of x minus g of x dx. Okay, and that is one of the formulas for area. There's another one where we have y's, but we'll see in the second method that we end up getting the same integral. So the other way we can see this is if we take, say, this area from A to B, and we want to find the area inside, we can do what we normally did when we found our Riemann sum of, say, just f of x. We would take a rectangle, but instead of to the origin, we're just going to look at the area from f of x to g of x. And we'll have the sum of the height of each rectangle. So the height times the width of each rectangle, which is going to be the sum of the height of the rectangle. So that's going to be f of x sub I minus g of x sub I times delta x, and we'll just take the limit as delta x goes to 0. And this will give us the integral from a to b of f of x minus g of x dx. Okay, now a question that you might have is, why do we take f of x minus g of x? And if we did g of x minus f of x, we would get the same area, except it would be negative. So what we're always going to do is we're always going to take the upper curve minus the lower curve, dx, from a to b. Now, let's take a look at the exact procedure of finding the area between two curves. So the first thing we're going to do is we're going to graph. And by graphing, that'll help us with step 2. So from the graph, we're going to identify our upper and lower functions. And that's if it's a function of x. If it's a function of y, we're going to identify our right and our left curves, where the right will correspond to the upper curve and the left will correspond to the lower curve. Next, we're going to find our bounds. As we'll see in the next example, they can be given to us, but oftentimes we'll need to find our bounds. And we'll go through another example where we actually have to do that. And then we're just going to set up and evaluate our integral. So the area is equal to the integral of the top minus the bottom dx, or if it's a function of y, the integral of the right minus the left dy. So now let's take a look at an example. So let's find the area enclosed by the functions y equals x squared, y equals x equals 4, and x equals 5. So obviously our parabola here is going to be x squared. This line, so this parabola here, is x squared. So y equals x squared here. Our line here is going to be y equals x. And then we have x equals 4 and x equals 5 as our bounds. So the region that we're looking to integrate and find the area of is going to be this guy. Okay, so now that we've graphed it and we know what region we're taking the area of, let's go ahead and find the top and the bottom curves. So the top is this guy right here. It's just our x squared. So the top is x squared. And that tells us what our bottom curve is going to be. It's going to be this guy right here, which is x. So let's go ahead and plug x in for our bottom. Now, we have to identify a and b. Well, we're given a and b. We're told that we go from x equals 4 to x equals 5. So a is 4 and b is 5. And let's just go ahead and draw a square around everything that we need. So remember, our integral is from a to b. So the area is integral from a to b of the top function minus the bottom function dx. Okay. So our area is going to be the integral from 4 to 5 of x squared minus x dx. Okay. So now let's just go ahead and evaluate it. So the area is going to be x cubed over 3 minus x squared over 2 from 4 to 5. And then we just plug in 5. So 5 cubed is 125 over 3 minus 25 over 2. Minus, when we plug in 4, 64 over 3 minus 16 over 2. And then we can clean that up a little bit. 125 minus 64. That's going to be 61 over 3. And then negative 25 plus 16 is going to be negative 9 halves. Multiply this whole thing by 2 over 2, this whole thing by 3 over 3. So it's going to be minus 27, and then 122 all over 6. And so 122 minus 27 is the same as 100 minus 5, so 95 over 6. As promised, not all problems give you the bounds explicitly, and we're going to have to find them in some cases. So let's look at one such case. So if we want to find the area of the region enclosed by y equals x squared and y equals x, we're actually looking, once we graph, at this small sliver right here. So let's go ahead. We've already graphed it, and we've found the region that we're looking to integrate. So let's identify the top and the bottom curves. So our top curve is going to be actually the straight line y equals x. So the top is x, and we'll just put that right down here. And that tells us that our bottom curve is going to have to be our parabola. So our bottom curve is x squared. So now we want to find a and b. So it's not given in the problem, and we're going to need to find it ourselves. And what we notice about a and b, or the bounds of our area, is that they're right here at these two spots where our two curves meet. So let's just go ahead and set the curves equal to each other. So we're going to set x equal to x squared and then solve for x. And when we do that, we get x equals 0 and x equals 1. So this x equals 0 is going to be our a, and this x equals 1 is going to be our b. So now when we set up our integral, we already have everything we need to know. A is 0, b is 1, our top curve is x, and our bottom curve is x squared. And that's it. So now let's just go ahead and evaluate this integral. X squared over 2 minus x cubed over 3 from 0 to 1. And so that's 1/2 minus 1/3 minus the quantity of 0 halves minus 0 thirds. This thing can go away to 0. And we have 1/2 minus 1/3, or 3/6 minus 2/6, or 1/6 as the area of our region. For our final example, let's determine the area of the region bounded by x equals negative y squared plus 10 and x equals y minus 2 squared. So I've graphed it a little bit. We can extend out one of the parabolas. So the white parabola is y minus 2 squared, and the red parabola is negative y plus 10. So we're looking at the region in between these two parabolas, which is pretty much the purple region here. So what is the right curve and what is the left curve? So the right curve is going to be right here, and that's going to be our red parabola. So the right curve is negative y squared plus 10. And our left curve, which is our lower bound of our region, is going to be our white parabola. So the left region is y minus 2 all squared. Okay, next we have to find our bounds. So they're not given, and we're going to have to find them. So as before, we're just going to look at these intersection points where they meet up. And to find out what those exact values are, we're just going to set them equal to each other. So negative y squared plus 10 is equal to y minus 2 all squared. And once we go ahead and we set up this equation, we can solve for y. We get y is equal to negative 1, and y is equal to 3. Okay, and does that make sense? Yes. So this looks like it's about 3. This looks like it's about negative 1 once we project it to the y-axis. Okay, so now we just need to set up and evaluate our integral. So it's negative 3 to 1, or my apologies, negative 1 to 3 of our right curve, which is negative y squared plus 10, minus our left curve, y minus 2 squared dy. And we can go ahead, you would FOIL it out, combine your like terms, go through the whole procedure of just doing the baby integration, and we get that our region has an area of 64 over 3. If you have any questions, comments, or concerns, please leave them in the comments below. If not, I will see you next time. As always, thank you for watching.